So let's look at adding equations. Diego is solving this system of equations. Remember, a system is more than one equation, and he's adding these two equations together, here. And let's see what happens. So we've got some work that is done there. Notice a line is drawn below the system, and it looks like there's a plus sign there. So it looks like he's adding them together vertically right here. So 4x plus negative 4x is 0. 3y plus 5y is 8y. 10 plus 6 is 16. So it looks like he is adding the equations together vertically and then solving for the y variable. Notice that the x disappears and you just have the y that's left, and then he solves for it. But then once he's got the y variable, then it looks like he's plugging that back into the equation. So notice this equation right here is essentially what he's plugging it into here. And he's plugging it in for the y, so the y becomes 2, and then solves for the x. And then he has the x and the y, or the y and the x. So what did Diego do to solve the system? So Diego added the two equations together. To get a third equation solved for y to get y equals 2. Then substituted 2 in for y. In one of the equations. And solved for x to get x equals 1. All right, so that's quite a bit that we tried to write in that little space there. You might want to pause and make sure that you get that written down, or if you want to paraphrase it yourself, that is fine. But what we want to notice is that we added the two equations that allowed him to solve for the y variable. And once he had the y variable, he could plug that back in. He could substitute that in, which allowed him to then get the x variable. So is the pair of x and y values that Diego found actually a solution to the system? How do you know? We've been talking about this now for really a couple of weeks, and that is that a solution is simply a set of values for the variables that makes the equations true, that makes the equations work. So one way we talked about finding a solution is simply taking the equation. Let's take the first equation, 4x plus 3y equals 10, and let's see what happens. So if we have 4 times 1, because our x value is 1, plus 3 times 2, because our y value is 2, does that equal 10? 4 times 1 is 4, 3 times 2 is 6, 4 plus 6 is 10. So yes, it works. And if we do that same thing for the second equation, remember the second equation is the negative 4x plus 5y equals 6, is negative 4 times 1 plus 5 times 2 equal to 6. Negative 4 times 1 is negative 4. 5 times 2 is 10. And yes, negative 4 plus 10 is equal to 6. So yes, both pairs of values, x, y values, make the equations true. Okay? And also, if you graph this, you are going to find that that point 1, 2, is the intersection point of these two lines. So if I graph the two equations, 1, 2 is the intersection point. Since we've done that a few times, and we will do that a few times more here, I'm not going to actually show that in the video, but if you want to, just pause the video and just try that for yourself. So take each one of these equations and put them into Desmos and see if you can see that that point 1, 2 is actually the intersection of those two lines. Remember, that is how we confirm the solution. All right, the first step in Diego's solving method was to add the equations together. Is this a helpful step when solving these two systems? All right, so let's try it out here. If we add these together vertically, so up and down, remember this is like a 1x and this is like a minus 1y. But if we add them together, 2x plus 1x is 3x. 1y plus negative 1y is 0. And 4 plus 11 is 15. So I would say, yes, kind of like Diego's method up here, that was helpful because now the y value is eliminated and we can very easily solve for x. Yes, since we can now solve for x. All right. And get a value for x. I might just say y was eliminated for the moment anyway, and then we can plug that in. You could probably do a little quick mental math. If 3x equals 15, then x must be equal to 5. Dividing both sides by 3, 3 times 5 would be 15. So I can get that pretty quickly. Okay, well, what if we added these two equations together over here? And again, we're going to add them like terms, so that would be 16x. This would be, remember, that's like a 1y, so plus 12y. 11y plus 1y is 12y. And then we have 37 plus 7, which is 44. Was that helpful? Not really, because now we still have an x and a y, and if we want to get a value for x or y, we really need just one variable so we can solve it and get x is equal to a number or y is equal to a number. So in this case, it kind of created a third equation that wasn't easier and didn't help us solve for a variable. So no, we still have both x and y variables, so can't solve and get a value for x or y. Nothing was eliminated. When I say nothing, I mean neither variable. Neither variable was eliminated. Okay, so you can kind of see what we're starting to do here, kind of a different method that allows us to solve for one of the variables. Sometimes it works and sometimes it doesn't when we add the equations together, but when it does work, it's very helpful. So we're going to follow this to its conclusion now on the next couple pages.